Good day, students. Welcome back to our second part of the series. We are still looking at the University of Limpopo exam paper that was written on the 27th of October, 2022. And please, if you are new, don't forget to subscribe to the channel for more mathematics content in Mzansi context. Today, we're going to be looking at the application of derivatives, and that is your increasing and decreasing and concavity, also the critical values there. That is question 4. And then question 5, it's primarily your integrals. And question 6, that's your application of integration. So we are going to be looking into those 3 questions, 4 to 6. We did question 2 the previous lesson. Please make sure you rewatch that if you haven't done that, to get the geographical view as to how I solve question 2 and 3. That was basically limits and derivatives there. So let's check question 4 without wasting time. They are saying let x. I guess this should be f at x. I don't know why they keep making mistake. Even this one, they really did the same stuff. But let's hope it was corrected in class. 4.1. They say find f prime. So you're given the function there. That is f at x is equals to x cubed over x squared plus 1. So let me just write that stuff. That is the question 4. So question 4, you are given, let's check, you are given f at x, which is equals to x cubed divided by x squared plus 1. That is f at x. Now, the first question, what are they looking for? That is 4.1. Let's check what they are looking for. They are looking for f prime at x. So because that is a quotient expression, I'm going to use the quotient rule. And that means that I have to square my denominator and drive. Let's square our denominator firstly. So that is going to give us x squared plus 1. This is squared. Now you need to differentiate your numerator. That is going to give you 3x squared. Let's keep our denominator. That is going to be x squared plus 1. We now need to take away. We keep this one this time around. That is going to be x cubed. We differentiate the denominator, and that is going to tie us down to 2x. That is if you do it nicely. Let's check now. This is really going to give you, I'm going to simplify it for you. That is x squared plus 1, and then that is squared. And then if you multiply that nicely, it's going to give you 3. Let me just say this is 3 x to the power 4 plus 3x squared, and then minus this should ties down to what now? This will ties down to, I think it's going to be 2x to the power 4 as well. So you basically have some like term there. Let's check, what are you going to get? Okay, let me just reduce this. We get x squared plus 1. That is squared. You can see that these terms are really the like terms. And then it's primarily going to give you a situation of what? This is going to be x to the power 4. And then the other one is plus 3. And then you're going to be left with 3x squared there. So this is what you're going to have for this derivative. And if you want to simplify it to show that you basically know this stuff, so this is going to be x squared plus 1 all squared. Check. You can take out the common factor there. That should be what? That should be x squared if you are to do that nicely. And then you'll be left with what? With x squared plus 3. This is the simplified answer of the first derivative. You can just leave it here, or you can just leave it here depending on the marks allocated. So this is the simplified answer for the first derivative there. The second question, what are they looking for? Let's check. They say that determine the critical values. So what are the critical values? Here we are talking about the stationary values, or the x coordinates of the turning points. Those are the critical values of f. So how do you find those guys? That is 4.2, I presuppose it's 4.2. So we want to find the critical values. The critical values will be found when f prime at x is equals to 0. We call them the x coordinate of the turning points, which is the critical values, or we can say those are the stationary values, the stationary x values primarily. So you have found your derivative to be this one, so you can really copy it, that is your f prime, and put it here and say that stuff must be 0, and from here you can solve for x. Remember that this is over 1, so you can really cross multiply that. So that should really give you x squared into x squared plus 3. That must be, well, it must be 0. If you cross multiply those two, they should really give you 0 there. Let's check. You can see that it's already factorized. Hence, I had to simplify this one so that whatever question that may arise after that, I may be able to solve it. All right. So this will then mean that you are going to have x squared is equals to 0, the first factor, or x squared plus 3 is going to give you 0. So this will then tell us that you have two repeated critical values here. That is x is equal to 0 or x is equal to 0. But we write only one of it. So that is x is equals to 0. We have this one. And then for this particular one, you can say that there's no solution here. You remember you are dealing with real numbers, so you do not have a solution there. That is no solution for that one. You can write that there's no solution there. If you want to give a reason, it's primarily because the discriminant will be less than 0. So the roots will be non-real. There. So that's how far you can go with the critical value. So the critical value primarily here is this one. It's only this one. But they are repeated because it's x squared. So the roots are primarily repeating. All right. There are two, but you write one, because they are repeating. We call it the repeated roots. All right. The next question. Determine the critical points of f. So they want the critical points of f. What are the critical points of f? It's like finding the turning points. So you say 4.3. Y will be found by when you take the critical value and put it in the original function. So that is going to be f at 0. So you're going to put 0 in f. We are going to put f at 0 there. So what is f? F was given as x cubed over x squared plus 1. So this is going to be equals to 0 cubed divided by 0 squared plus 1. And as a result, this will boil down to 0 over 1, so therefore y value, y value is going to be 0. So the critical points are going to be 0. Let me just put it here that these are the critical points. Therefore, the critical points are, these are 0 when x is 0 and also when y is 0. You plug it into the original function to get the corresponding y value of the stationary point or the critical points there. So this is how you go about it. Now the next question, what are they looking for here on the next question? Let me scroll up there and really check what are they looking for. 4.4, determine the intervals where f is either increasing or decreasing. So you want to check the intervals where f is either increasing or decreasing. So think about it. I'm going to say 4.4. We are from 4.3. So if you are talking about increasing and decreasing, like I said, think about it, guys. If say maybe you are dealing with a function which behaves like this, that is a cubic graph, and we say for which values of x or the intervals where this guy is going to decrease. So that is going to be influenced by the turning points. That is going to be, say maybe the x is equals to maybe -1, and then here x is say maybe 5. These are the critical values, by the way. They determine the increasing and the decreasing situation. So if you check from here, the graph is going to increase, and also from here the graph is going to increase. And then the decreasing situation is going to be primarily here. This is where it's going to decrease when you're dealing with curves. So it means the interval for this one is going to be x is less than -1, or x is going to be bigger than 5. You know, you can really do it in this way, or you can say that the interval for when f is increasing is when f prime at x is going to be bigger than 0, or f prime at x is going to be less than 0. It's when the graph, here it's for decreasing, this one is for increasing. So because for this graph, I'm not told to sketch it. I'm going to use the basic principle to say that I have the critical value of it, and I found that to be x is 0. All right, so I'm gonna analyze based on this information to say, well, think about it. This is your number line, and then at this point you have x is equals to 0. So that means in this region is -infinity to 0, I mean to say, to 0. And then here it's from 0 to positive infinity. Think about it. Think about it. We are saying that this graph is going to increase if and only if f prime at x is bigger than 0. So let's have our f prime. Let's have our f prime. Our f prime, we found it, by the way. That was something simplified, x squared. You can even use this one to make your life easy. X to the power 4 plus 3x squared. So we're going to get 3x to the power 4 plus 3x squared divided by x squared plus, that was 3, right? And then all squared. I think this will also be x to the power 4. Let me check. Yeah, x to the power 4 plus 3x squared over x squared plus 1 to the power 2. Yeah, you are going to have this one as the first derivative. So think about it, guys. You want to check where it's going to increase. So it's going to increase if and only if f prime at x is bigger than 0. That means positive. So what I will do is I will say to myself, let me test on this interval, because I only have 2 intervals, which is this one and that interval. So let me test on this interval to say at the interval -infinity to 0. I want to test here. So how do I test? I take any number that belongs here. So I can take -1 just right there, because it's really, I don't want to add with big numbers. So I want to add with small numbers. I can take -1 that is here and test it to say, what is f prime at -1? I'm going to put -1 there. So if I do that, I'm going to get 1. -1 to the power 4 is primarily +1, plus negative 1 squared is 1 times 3. So this is going to be 3 divided by, if you put negative 1 here, it's going to be, let's check that. Wait a bit. Oh, that should be 1, for this particular situation here. It should be 1 as per function, as per your derivative there. I wrote 3 instead of 1. I don't know why, but I hope you forgive me for that. So if you put 1 there, here, it's going to be 1 and then plus 1, and then you square that stuff, you know. So that is really going to be 4 over 2 squared is also 4. And what are we going to get? We are going to get 1. That is really simple, and that is bigger than 0. So we get something which is bigger than 0. So therefore, we are going to say to ourselves now, therefore, f at x is increasing on the interval. On the interval, it's from negative infinity to 0. This is where f is going to increase, because f prime at x is bigger than 0 at that interval. You can take any x value in this interval, any x value here, any x value. This graph is going to increase everywhere. You can take negative 5, any x value there, just to check if it's going to be positive or negative. Let's take the other one now. I'm going to say at the interval, you are now going to test the other interval. That is the interval from 0 to positive infinity. So we're still going to check f prime at any number here. So let me take any number which belongs here. Like I said, I want to work with small numbers. So any number just right after 0 is going to be positive 1. You can take 5, 3, and whatever that you want to take there. I'm going to take 1 because that is a small number, and I don't want to, you know, stress myself thinking about that. So it's 1. I'm going to put 1 into this equation. So if I put 1 here, it's going to be 1 to the power 4, which is 1. So it's primarily going to give me the same result here. So I may really need to copy it to say that, let me paste it here. It's really giving me the same stuff, which is bigger than 0. So that means the conclusion is the same even here. This graph was increasing everywhere on the x-axis. I tried to draw it for you, and then I will share it on the comment section below, the sketch of this graph. It was increasing everywhere on the x-axis. So you say that this is increasing on the interval that is 0 and positive infinity. Yeah, this is how you really go about it. The issue of increasing and decreasing, extremely easy, right? And if you have any question, please guys, don't forget to comment. I will really read your comments below. I love it when you guys comment, and don't forget to subscribe. Now, check 4.5. Find the f double prime, so that is the second derivative. We want to find the second derivative. That means we are going to derive the first derivative, which was primarily this one. So our first derivative was this one. That was our first derivative. So let me differentiate this one, this one. So that is 4.5. We are now going to 4.5. I'm just going to paste this one here. We want to differentiate this one to get the second derivative. So this would be very easy. F double prime primarily. Let's check what are we going to get here. That should be very easy. Very easy. So that is going to be x squared plus 1 all squared. So I'm going to really square that denominator, which is written in this way. I'm now going to differentiate my numerator. If I drive that, should be easy. That should be 4x cubed plus this should be 6x. All right, should be very easy. And then you now keep your denominator. That is x squared plus 1 to the power 2. And then you say minus now. Minus. You now keep your x to the power 4 plus 3x squared. You now multiply this by the derivative of the denominator. So I need to enlarge this one. If you derive the denominator, what are you going to get there? If you derive this one, you're going to apply the chain rule to derive this. So that should be 4x into x squared plus 1. That is the chain rule. For those who are a bit confused, to derive this one, I want to differentiate x squared plus 1 all squared. If you derive this, you'll bring down the power, which is going to be 2. This is going to be 2. You keep what is inside, that is x squared plus 1. You take away 1 from the power, so it's going to be 1 times the derivative of what is inside, which is going to be 2x, and then 2 times 2x, that is going to be 4x into x squared plus 1. This is how I got this one. For those of you who have questions on how I got 4x into x squared plus 1. Just to clear up the air there, that's how you really get that one. And you can simplify this if you want. You need to simplify it. Let's simplify it and check what are we going to get. Yeah, I think we may really struggle a bit to simplify that stuff. Okay. Let's do it in this way. I trust my capacity. So to simplify this, you need to have your 4x cubed there plus 6x. You now need to deal with this one. So that is going to be x to the power 4 plus 2x squared, and then a plus 1 there, minus, if you try to expand that, you must really arrive there, and then minus, that should really be 4x into x to the power 3 plus 3x squared into x squared plus 1, just like this. This is what you're going to get. So you need to clean up the numerator. You must really clean up that numerator. You may need to give me a second to clean up, because I see that I may be here for more than 5 hours. So allow me to simplify it on my computer here. I just want to simplify it for a moment. Give me a minute, I'll be done. Expand, I'm just really simplifying this stuff and see something. So that is going to be 4x cubed plus 6x into, okay, I'm just gonna do that, then plus 1 all raised by 2. Okay, so I'm gonna get to 4x to the power 7. Okay, so let's get it. If you simplify this nicely, you're going to get 4x to the power 7 there, plus 14x to the power 5, and then plus 16x to the power 3 plus 6x minus this multiplication as well. So allow me to really write that multiplication here in my computer, and you'll be doing it that side to verify what I'm getting also this side. So I'm going to write that is 4x into that is x cubed plus 3x squared into that is x squared plus 1. It's going to give me this stuff here. So let me check something. Expand that. That is 4x. Okay, 3x squared. This is 4x into 3x cubed. Let me primarily do it in this way. Open the brackets here. And then they're all in brackets. Still give me the same stuff there. Okay. So let me just simplify that stuff. Let me just really do it in this way. I want the oversimplified one, so this time is 4x. So it's going to be 4. It's going to be 4 into x cubed, and then plus 4x. This is what I wanted. So this gives me 4x to the power 6 plus 12x to the power 5, and then plus 4x to the power 4. Let me increase that. You must expand it to check if it's the same stuff. And then plus 12x to the power 3. I need to really, I don't know why they will give you this thing in the exam. It really requires a lot of analogy, because you still have to simplify that stuff now. So I'm going to do it simply. Simplify this one. I'm just gonna copy it and paste it here. Let's say minus. This should be a minus situation. And then I copy the whole of this and paste it here. Say equals to. So that is really going to give me some niceties here. So this gives me, guys, 4 x to the power 7 minus 4 x to the power 6, and then plus 2x to the power 5, and this is minus 4x to the power 4, and then plus 4x cubed plus 6x. This is what I get for the second derivative. It's the oversimplified one, and I can also simplify the denominator to be everything to the power 4. Like I put a 4 there. This is x squared plus 1 to the power 4. I hope you also know that logic as well. We are basically multiplying this 2 and that 2. So this is how far I'll go with the simplification of the second derivative. It really ends here. I'm going to duplicate that and really put it here so that I save time. I've been wasting time by simplifying this stuff. So, but it's worth it in the exam room, eh? It's really worth it. Let's check. I don't know how many marks was this, but it's worth the marks. Find the points of inflation of f. We want to find the points of inflation of f. Okay, so how are we going to do this? The points of inflation occurs at the second derivative, right? So that is 4 point, it's 4 point what? It's 4.6, 4.6. So 4.6, we want to find the point of inflation. The okay is when the second derivative of x is equal to 0. And be very careful. The point of inflation and the critical values, basically, it's what makes the graph to be 0 and also what makes the graph to be undefined. So for this graph, it's going to be defined everywhere because you have x squared plus 1. So whatever value of x you're going to have here, this graph will never be undefined because of x squared. Whether it's negative number, there's no way you're going to get a 0 in your denominator for any value of x. So now I'm going to say to myself that this second derivative is going to give me the point of inflation, this stuff here, that must be 0. So you can really cross multiply. Like I said, remember here it's over 0. It's over 1. So when you cross multiply, you are going to get this situation, this one here. You say that must be 0. That must be 0, eh? And then you solve for x. You're like, my way. Mathata fella. So, but you can factor out your x here. It's really easy. Go back to grade 9. You can take out 2. 4 is really common. So I'm going to take 2 because it's common. So I'm going to take 2x. I'm going to take 2x as a common factor. It's going to be 2x into, I'm left with what now? Now I'm left with 2x to the power 6 and then minus 2x to the power, I guess it's 5. And then now I'm going to be left with plus x to the power 4 minus 2x to the power 3. And then plus, this should be 2. This should be 2x squared plus this should be 3a is equals to 0. Well, let me just try to check and factorize that stuff because I want to get all the factors. Once you can factorize that, you are going to be in trouble. I need to be sure of the factors primarily because you can see that we're dealing with the heavy problem. So I'm trying to get the factors. Yes, it says that the factors are these ones here in my computer. So this is going to be 2x into x squared plus 1 into 2x to the power 4 minus 2x to the power 3 minus x squared plus 3 is equal. I don't know why they will give you such a Hindoras equation to solve, but you are likely to face it. You are in varsity, you should be able to do that. Now you are going to solve for x. You can clearly see that 2x would be 0, or x squared plus 1, it would be 0, or 2x to the power 4 minus 2x to the power 3 minus x squared plus 3 must also be 0. The beautiful part of this is that here we do not have no solution. Even here we do not have no solution. It's a beautiful stuff, eh? So it means that our x ties down to 0 as well. So we have only one x. This is the x of the inflation. This is the value of, it's the x value of the point of inflation. So you want to get the points of inflation. You are going to plug it back to the graph. So you see, well, y is going to be found by f at 0, and that is 0 cubed over 0 squared plus 1. This was our function, x cubed over x squared plus 1. So that should really ties down to 0 over 1, and the answer will be 0 for y. Therefore, the critical points, the point of inflation, find the point of inflation, yes. So the point of inflation, therefore, the points of inflation is, you write them down, that is x is 0 and y is also 0 there. This is how far I will go with this. I'm just concerned about the factorization of this. Why would really they do that for you? That is a long walk to freedom. Let's check now. They say 4.7, determine the intervals of concavity of the function of f. So we're looking for the concavity. That means the concave down and the concave up. And that is primarily at your point of inflation. The point of inflation really determines the concave down and the concave up. It's the change in concavity. So I'm going to have 4.7. Think about it. If you are dealing with a high school graph like cubic, which behaves like that, you are going to have the point of inflation there. Say maybe x is equals to 1, for an example. This graph is really going to be concave down this side. This is going to be concave down that side. And here it's going to be a concave up. How do you then analyze that in geographical terms? You basically say that for concave down, the f prime at x is going to be less than 0, and then f prime at x is going to be positive. This is how you find the concave down and concave up. So this should be concave down, and this should be concave up. So it's concavity. So it means this region, the second derivative is less than 0, and in this region the second derivative is positive. It's basically the concavity, the change in concavity. So I'm just going to do it with the precalculus way. That is to check the second derivative, if it's positive or negative. So remember that you had your second derivative somewhere there. It's that tedious thing here we got. My goodness. It's primarily this situation. Just gonna copy it. That is my second derivative. I'm going to put it here for you. Let me resize it. So this is a second derivative, and we got the point of inflation, the x there, that is 0. So we're still going to use the same interval primarily, like 0, and we say that here is negative infinity to 0, and then here from 0 upwards, that is 0 to positive infinity. So I'm going to test the concave down now and concave up. So I'm going to say that at the interval, so the interval is negative infinity to 0. So you want to check the f double prime at the number that is here. That is going to be -1. I'm going to really take -1 there. I don't want to really kill myself by taking big numbers. You can take anything in this interval. So I'm taking -1 because it is doable at my disposal. I'm going to put x is equal to -1 here and see what do I get. I'm going to have my calculator now. That is 4 into negative 1. I raised that by 7. In fact, I can even do it with my calculator, with my mind. So it's going to be negative 4, and then negative 4 again, and then negative 2, and then negative 4, negative 4, negative 6. So that is negative 24. So that is negative 24 divided by, I put negative 1 here. That is going to be 2. Negative 1 squared is 1 plus 1 is 2 to the power 2 to the power 4. 2 to the power 4 is primarily 16. And that should really ties down to negative 3 over 2. And that stuff is less than 0. So you can see that f double prime at x is less than 0 on the interval that is negative infinity to 0. So this would then mean that f is concave down on the interval negative infinity to 0. This is where f is concave down. You want to check the concave up now. You do the same stuff. That is to say that f double prime at positive 1. Let's just write where we are coming from. So we are going to say on the interval, this other interval now. I'm going to say that on the interval, the interval is 0 and positive infinity. So I'm going to say now that at that interval, let me find f double prime at positive 1, the one that is here. So I'm going to take 1 now, just right after 0, that is positive 1, and plug it into the equation here. Put positive 1 here. So let's check. If we put 1, it's going to be 4 minus 4, and then plus 2, and then minus 4, plus 4, plus 6. The answer is positive 8. Let me confirm. 4 minus 4 plus 2 minus 4 plus 4 and plus 6. So the answer is positive 8 there. So that is 8 over. If you put a positive 1 in the denominator, it's still going to give you 16. So you have 16, which is equals to 1 over 2. This is 16. So a half is primarily positive. So you're going to say now that therefore f double prime is positive on the interval. The interval is from 0 to positive infinity. So this implies that f is concave up. F is concave up on the interval that is 0 and positive infinity. This is where this guy is concave up. That should really be very easy, and that should really suffice to the question. They said determine what? The concavity on that particular stuff. Determine the intervals of concavity. So you really found them. 4.8, find the oblique asymptotes of f. So you want to find the oblique asymptotes of f. That is the last question. 4.8, find the oblique asymptotes of this graph, x cubed over x squared plus 1. So you can see that the degree of the denominator is lower than the degree of the numerator. So that means the oblique asymptote, which is known as the slant asymptote, is going to be here. So we use long division to do that stuff. So to do that, let me just really do it nicely. Then I'm gonna have that just really be straight line there. So that is going to be x to the power 3, the numerator, and you get x squared plus 1 there. We are going to do long division, guys. How do you then do that? You say, what variable will I multiply with x squared and it gives me x cubed? So that is primarily x. Yeah. So this x times x squared is going to give you x cubed, and then x times 1 is primarily going to give you x. So you need to close that and really multiply by the negative of that, and really now add them, the results, and really get what is happening there. When you add the two, that really becomes a negative x if you add those two situations. So what you are saying primarily is that this function here, this function, because you can see that you can't reduce it further. By that I mean you ask yourself, what is it that I can multiply with x squared and it gives me negative x? That thing is not there. So you end there to say, this means that this graph, this one here, is equivalent to that remainder there, that is x there minus this one over the denominator of the polynomial, which is x squared plus 1. And I want to warn you, if you simplify this back, it must give you this one. It must really give you that one. If it doesn't, it means it's not really true. So this graph here, my goodness, this graph is the same as that one. So you are basically saying that the oblique asymptote is this one. Or you can just say that is my remainder in there. So therefore, the oblique, which is known as but here they're asking the oblique. So let me write it like the oblique asymptote is going to be equals to y equals to x. There we go. That is the oblique asymptote of that particular graph. It's a very easy situation, eh? Like really easy. I want to work the integral now. We want to look at integrals. I hope you are going to be following as well. So integrals are the easiest stuff. There is one just need to be very organic in terms of the techniques as which one you're going to use. Question 5, evaluate the following integrals. They say that this is x squared plus 2x into x cubed plus 3x squared plus 1 to the power 15 dx. So you want to integrate that stuff. Really easy. So let's check that. That is question 5. Integration. That is 5.1. You want to integrate x squared plus 2x into x cubed plus 2x to the power 2. I think it's plus 3 there. I need to really be careful. And then plus 1. Everything is raised to the power 15 dx. Let me confirm that. That is x squared plus 2x into x cubed plus 3x squared plus 1 to the power 15 dx. So you want to integrate this one. Okay, so I'm going to use substitution on the premise of the fact that if I differentiate what is inside, it's primarily going to give me that one. So I may as well need to rearrange it nicely to say that that is the integral. That is the integral of x to the power 3 plus 3x squared plus 1 to the power 15, and then I multiply this by this one, so that is x squared plus 2x dx, because already I've seen that if I derive this, it's going to give me that one, so that is u substitution. Therefore, let u to be x cubed plus 3x squared plus 1. So you want to differentiate this. So this will then mean that your du is going to be 3x squared plus 6x plus 0 dx. You can factor out your 3 here. This is du. You take 3 there. That is going to give you primarily what you have saved there. If you take out 3 out, so it's what you've been looking for, 3x squared plus 2x. So you can divide both sides by 3. That would mean that you're going to have 1 over 3 du, and then it's going to equals to this particular stuff here. So you're just going to replace everything into the integrand to say that therefore now the integral of this, that is u to the power 15 multiplied by this one, which is this one, it's going to give you 1 over 3 du. So that is 1 over 3 du, which is equals to 1/3 the integral of u to the power 15 du. And as a result, you get 1/3 into 1 over 16 u to the power 16 there. Don't forget to write your constant c, but you need to simplify this a bit. 1 over 3 times 1 over 16 is primarily 1 over 48. So that should be 1 over 48 times u. Your u, it's x cubed. Remember that, x cubed plus 3x squared plus 1 to the power 16 plus c. That should then suffice to that particular integrand. It's worth the struggle, trust me. It's really worth it. That's how I'll go about that integral. It's 1 over 48 into x cubed plus 3x squared plus 1 in raised to the 16th power plus c, the constant. Let's check the second part of it. It should really be easy as well. The integral of e to the power 2x cos x. Okay. So those are integrals. And how I will go about it, it's 5.1.2. The integral of e to the power 2x multiplied by cos x dx. So that is by parts situation. I hope you guys understand the techniques there by parts. That is the exponential function, and that is the trigonometric function. So, and that makes it to be product. So, but the derivative of this, it can't give you that, and the derivative of this can't give you this one, and even this derivative can't give you any of those there. So it's by parts. So I'm going to use by parts to do this, where trigonometric is your u and dv is going to be this other one. Therefore, your u will be trigonometric one, and dv is going to be e to the power 2x. You put dx there, you want to get du and v. Therefore, du is going to be this derivative, that is negative sine x dx, and then v, what do you get there if you integrate that? You get 1 over 2 e to the power 2x. That is your v. Well, you then say to yourself now that this stuff is going to be uv minus the integral of v du. You primarily have everything to substitute here. That is u and that stuff. So you're going to get 1 over 2 e to the power 2x cos x. All right. Cos x minus the integral of v du. So v is 1 over 2 e to the power 2x, and then du is this one. So that is a negative of sine x dx. Then you can say that is 1 over 2 e to the power 2x cos x. You can really take that negative out with the half. So if you take them out, they become positive, negative, and the negative, they become positive. Remember that if you take this negative out, it's really going to become positive, but there's a half there which must go out as well. So please accommodate it. So you are going to be left now with the integral of e to the power 2x and then a sine x dx. So you will see that this integral, it's really by parts again. We call this type of integration repeated integral by parts. So you want to integrate this one and find the answer of what is this one? What is it equals to? We are going to use by parts again to say that our u this time around is sine x and dv is equals to 2 e to the power 2x and then dx. Now you're going to get du is equals to cos of x dx, and v is going to be 1 over 2 e to the power 2x. That is v. So now this integral by parts again is going to give you something beautiful. That is uv. That is uv. You multiply them, they give you 1 over 2 e to the power 2x, and then sine x minus the integral of v. So v is 1 over 2 e to the power 2x du is this one, and that is primarily cos of x dx. Check now, that is 1 over 2. Let me just really copy it to save time. So that is really going to be here. And then I take this half out. So it's going to be minus 1 over 2. The integral of e to the power 2x cos x dx. Think about it. If you integrate this one, which was the problem that was asked to you, is this one. It means if you integrate it, you are going to come back to this step. So you stop here because it's repeating here. It's really repeating. So you stop here to say that, remember that you were integrating this one. So what I will do is I will say this integral right here, this integral, I'm just going to paste it here. This particular integral, it is equivalent to, it gave you this answer in the first place, this one. It really gave you that answer. So I'm going to paste it there, that answer. But check this one. This is going to be 1 over 2 and then e to the power 2x cos x, and then plus 1 over 2. This integral is the one that you just found, and this is the integral of it. You found that to be 1 over 2, is that one, e to the power 2x sine x minus half, the integral of e to the power 2x, and then that was cos now. So this is cos x dx. You close that. All right. Yeah, it was worth it, guys. It was worth the struggle here. Now, you're going to say that this is 1 over 2 e to the power 2x cos x multiplied by half everything. This becomes a positive 1 over 4. And then e to the power 2x sine x, and then minus 1 over 4, the integral of e to the power 2x cos x dx. So this is what the integral is equals to. This is what the integral is equals to. But think about it. This particular term here is a like term to this term here. These are your like terms. So what I will do is I'll bring this one to the left side to say, therefore, this one, I'm just going to put it here, this situation there, and then I say, if I bring the whole of it to the left, it really becomes positive. Let me just write that. It becomes positive of this one. Let's just duplicate it and really put it here. So because it's gone now, I may need to really delete it. So I'm left with this one. It's what is left to the equation. So these are your like terms. So what can you do? You can factor out the common factor, which is this integral, and then it will leave you with 1 for this term there, and then plus 1 over 4. That is really going to give you this stuff. Let me copy it, the whole of it. It's going to give you this one. So therefore, what is 1 plus that should be 4 plus 1, so it's 5 over 4. But let me verify. 1 plus 1 over 4. Yeah, I'm correct. So multiply by this one here. That is really going to be, that is equals to this situation just right here. So you need to solve for this one. What can you do? You want to solve this, you must divide every term by 5 over 4, or multiply each term by 4 over 5. So I'm going to have the integral of e to the power 2x cos of x dx is equals to, I need to multiply the whole equation by 4 over 5. So this multiply by 4 over 5. So you multiply this by 4 over 5. So I may need to really type it. I don't want to make mistakes. So 1 over 2 times 4 over 5. So that is 2 over 5. So that really give me 2 over 5 e to the power 2x cos x, and then plus, and now multiply 4 over 5 by 1 over 4 by 1 over 4. That gives me 1 over 5. That gives me 1 over 5 then of 2x, and then sine x. And don't forget to write plus c here. Don't forget to write plus c. I hope I didn't forget on the other one. I think it's the first one, yeah. I didn't forget to write plus c there. You know, that is your plus c. So what we can do now, if you love to simplify, this will be e to the power 2x into, that is really going to be 2 cos x over 5, and then plus sine x over 5. I took the common factor there, and that is e to the 2x. You can really leave your answer here, or your answer may really end here. Like you have a 5 there, and 2 e to the power 2x cos x, and then plus e to the power 2x sine x, and then plus c. You may really, one of these will be your option. I don't know which one you chose. That one, or that one, or that one. They are all correct. Just pick any of those. I just oversimplify. I love simplifying. I hope you have seen that. So I may have oversimplified that situation. That was 5.1.2. Let's check the next one, 5.1.3. What are they saying there? You know, these are integral. I hope we are halfway done. You know, these are integrals. So let's check. 5.1.3. The integral of 6x squared plus 21x plus 11 over x squared plus 3 into x plus 5. So that is partial fractions, right? That is partial fractions. Let's do that. Let's do that together. The integral of 6x squared and then plus 21x plus 11 divided by, that is x squared plus 3 into x plus 5 dx. So you want to really do this one. So I'm going to use partial fractions because the degree here of the denominator is going to result to x times that is x to the power 3. The highest degree is bigger than that 2. So I'm going to use partial fractions. And it's the quadratic case. I hope you have seen that, the quadratic case. And that is really going to be your ax plus b divided by this quadratic because you can't factorize it. So it's going to be x squared plus 3 plus c over x plus 5. I hope you know how to do this. You have to multiply by the LCD or by the LCM there. That is you're going to be left with this situation primarily. And plus 11 is going to be equals to ax plus b into x plus 5. Then plus c into x squared plus 3 in there. So you want to solve ABC by decomposition. You can see that if you want to solve for c first, because it's separated, to kill these two terms, a and b, you are going to let x to be negative 5. So therefore, let x be negative 5 there, and then you solve for c. You're going to substitute negative 5 there for x. And if you do that nicely, it's going to be 6 into negative 5 squared, so 6 times 25, plus 21 times negative 5 plus 11. That should ties down to 56 is equals to, that is 0, because of negative 5 as x. So I'm going to be having x, that is going to be 25 minus 5 squared is 25 plus 3, so that is 28, right? That is 28 c. So this means that my c is going to be positive 2 if I solve that nicely. That is the value of c. And now I may need to expand that, you know. Let's expand it. So let's copy this just right there, and we expand this situation. We are going to get ax squared plus 5ax plus bx plus 5b, and then plus cx squared plus 3c. You group the x squared one, that's going to be a plus c, that is going to be a plus c all squared. These two terms, you can take out your x squared, and then now plus these two have the x, so you're going to have 5a plus b, x there. Finally, your constants are going to be 5b plus 3c. You still have these ones, that is quadratic. Those are two quadratic stuff. So two quadratic polynomials are equal if and only if their coefficients are equal as well. Therefore, I'm going to say this 6 here is going to equals to this coefficient, and that is a plus b. The other equation is going to be 21 for x is going to equals to this term, and that is 5a plus b. And then the other one is a constant 11. It's going to equals to 5b plus 3c. So you want to solve these guys. So which one will you solve first? Let's solve for b because we have the value of c there. Let me check something. You can even solve these two simultaneously, the way I'm looking at it, but I'm going to solve for c first, for b, because I have the value of c as 2. So I'm going to really say that is 11 is equals to 5b, and then plus 3c. c is 2. So what are you going to get there? It's going to be 11. This is going to be 11 minus 6. Is it 5? That should be 5b. Therefore, b should be equals to 1. So b is 1 primarily. And you want to get for a. Your a, you are going to get it here or here. One of the two primarily. So your a, it's going to be very easy stuff, eh? You can even plug it here. That should really be very easy. Should be very easy. I'm trying to check if I didn't make a mistake here. Okay, I made a mistake here. This should be a plus b. I mean a plus c, so to say. That should be c here. 6 must be equals to this term, that is a plus c. All right. And then this one must be equals to 21. Yeah, I think that is correct. From there, you can verify it in many ways, because the first equation now has c and this has c. So if you want to get a, you are going to substitute the c here. And that is going to be 6 is equals to a plus c. c is 2. Therefore, your a is going to be equals to 4. Or alternatively, you can really plug your b there to get a. It must give you the same answer. Let's check it. This will be 21 is equals to 5a plus b. So b is what? B is really 1. So this becomes 20 is equals to 5a. Therefore, a is going to be 4 as well. So a is 4. And your b is 1. Your c is 2. So that means you have decomposed these fractions primarily. You have decomposed it. You are then now going to say that there it is, and that will be equivalent to a. So a is 4x plus b. b is 1. We got 1 over x cubed. X squared plus 3 plus c was 2 over x plus 5. So we want to integrate this problem, and it's now decomposed. This is now decomposed. You can further also say that this stuff here is the same as 4x over x squared plus 3 plus 1 over x squared plus 3 plus 2 over x plus 5. That is the same as that, so that your life is oversimplified when you integrate this. So that should really be the integral of this one here. because of space. It's fine. I think I have enough space. So I'm just going to really put it there, and then you'll do that. Well, so if you integrate those terms independently, that will be the integral of 4x divided by x squared plus 3 dx plus the integral of 1 over x squared plus 3 dx plus the integral of 2 over x squared plus 5. Oh, that should be x. I don't know why I'm saying x squared. That should be x plus 5. And then dx. This integral there. Now, you are going to say to yourself that let me take a 4 out. So that is going to be 4. You are now left with x over x squared plus 3 dx plus the integral of 1 over x squared plus, you can really say this is square root of 3, everything to the power 2. Root 3 squared is 3. And then a plus the integral of 2 over x plus 5 dx. And this should really boil down to, if you integrate this, it's going to be half a natural log of x squared plus 3 times 4. So this should really be 2, a natural log of x squared plus 3 plus, this is the tangent identity. The arctangent primarily, so it's going to be 1 over square root of 3 into the arctangent of x over a, which is the square root of that 3 primarily. And then you are now going to say plus this integral, the very easiest integral, a natural log of x plus 5. And then you now have to really put plus c there. And if you want to simplify it further, this should be the natural log of x squared plus 3. And then what is this number here? That number is primarily equivalent to square root of 3 over 3. That will be the arctangent of the same stuff. That should really ties down to square root of 3 x over 3. It's the same thing. And then plus now, this should be twice the natural log of x plus 5. And then you put a plus c now. Yeah, this is how I will really approach that question. Everything seems very clear from my side. I don't see any mistake here. After all, I'm the one who's doing it, so I'm not expecting any wrongdoings here. That is the correct way of doing it. Well, finally, the last integral, that is 5.1.4, sine raised to the 5th power. So the power is odd. So you're going to use square identities. And that is 5.1.4, the integral of sine to the power 5 dx. So really this power is the guiding factor here. So you are going to say to yourself, let me save one factor here. That is sine to the power 4 of x multiplied by sine x. It's the same as sine to the power 5. And then now you are going to have a 1 minus cos squared of x, everything to the power 2 multiplied by sine x dx, on the principle that this situation is sine squared to the power 2. It's going to give you sine to the power 4, times that, which is the same as the given problem. So I hope there's a sense of logic there. Therefore, now your u is going to be cos x which will be du equaling to negative sine of x dx, and this will ties down to let's say maybe it's negative du equaling to sine x dx, which is that one there. So you are actually fine. This becomes the integral of 1 minus cos squared, but your cos is u. So you will say it's 1 minus u squared, everything squared, multiplied by sine x dx, which is minus du, just right there. So this becomes minus du. And as a result, I'm going to take that negative out. So I'm left with 1 u squared all squared du. This should be very easy to do. It's negative of the integral. You expand that carefully. That is 1 minus 2 u squared plus u to the power 4. And then you have du there. And if you integrate nicely, this would be negative. And with respect to u, it's going to be u minus 2 over 3 u to the power 3 there. And then a plus 1 over 5 u to the power 5. And then you have to really put your constant c there. Now you need to plug back your u. So this is minus u, which is a minus cos x. And then this time that is positive, so it's plus 2 over 3 cos to the power 3 of x, plus now this time that is really becoming negative. So I may need to refrain from that and say it's minus 1/5 cos to the power 5 of x, and then you need to really put the plus c there. Extremely easy, and that brings us to the end of the integration problem. Well, we are going to question 6. Question 6, what is happening there in question 6? Let's check that stuff there in question 6. Yeah, we've been doing this, Question 6, evaluate the integral from 1 to 2 of what? Of 2x to the power 1 over 3 plus x into x squared plus 1 into, raised to the 6th power dx. So that should really be very easy. Let's do that. Really easy, Let's check the integral of from 1 to 2 basically, and that is 6.1. I need to emphasize that is 6.1. And then you have 2x to the power 1/3 there, and then plus x into x squared plus 1 to the power 6. You close that dx. So I'm going to apply the sum of the integral, which is going to be the integral from 1 to 2 of 2x to the power 1 over 3 dx plus the integral from 1 to 2 of x squared plus 1 and then raised to the power 6 dx. Well, that should really be very easy, guys. You need to integrate this carefully with that power there. So if you do that, let's check what are you going to get. You are primarily going to divide 2 by 1 over 4. If you divide 2 by 1 over 4, you're going to get 3 over 2 x to the power 4 over 3. It's that integral. And then your bounds are primarily moving from 1 to 2 there. Same stuff with the other guys. That integral, it's a u substitution. That is a u substitution. And if you do that nicely, your u is going to be this. So it's going to be half. Now it's going to be 1 over 2 u to the power 6. So it's going to be u to the power 6. And then now you are primarily Going to integrate that. I'm trying to check something. There is a half already there. So u to the power 6 is, I think it's going to be 1 over 7, eh? Let me do it. So that is u equals to, yeah, I think it's 1 over 14 now. Okay, so that is 1 over 7 u to the power 6. You close that, and then the bounds are from 1 to 2 as well. Let me just copy this the way it is. I didn't really do much there. And then a plus, that should really be 1 over 14 u. So u, I think that power there as well should be 7. This should be 7. And then your u, that is x squared plus 1 there. Everything to the power 7. And then that should move from 1 to 2. And then you want to apply the fundamental theorem of calculus. That is going to be 3 over 2 here. And then you put it to where there is x. So that is really going to be what now? That is going to be 2 to the power. Let me just really put it the way it is. It's going to be 2 to the power 4 over 3 minus 1 to the power 4 over 3. You close that. You say plus, same stuff this side is going to be 1 over 14. 1 over 14 into, you put a 2. So 2 squared is 4 plus 1 is 5. This is 5 to the power 7 minus, you put a 1 there now. It's going to be 2 to the power 7. That is 2 to the power 7. I'm trying to really simplify this. And as a result, you're going to get 3 over 2 into, this means the cube roots, the cube roots of 2 to the power 4. And then minus 1, this is 1. And then you close that, say plus 1 over 14. You can really find out what is that number. It's 5 to the power 7 minus 2 to the power 7. 5 to the power 7 minus 2 to the power 7. That gives me 77997 there. And then this end result is going to give me 3 over 2 into the cube roots of 16 minus 1 plus, let's divide that by 14. So that is 77997 divided by 14. I will really end here. You saw that I fought with my last breath to simplify this problem. So that should really suffice to the question. If I made a mistake, you can always comment that you saw the logic behind the integration. I think there's no mistake here, the way I'm looking at it. Just have to really look into that. There should be a sense there. All right. And then a 6.2. What are they saying? I didn't really check that question. 6.2. Find the length of the arc of the graph of f at x, which is equals to 4x to the power 3 over 2, and then which is in between x is equal to 0 and x is equals to 2 over 3. So that should really be very easy. You are given everything there. They give you f at x, that is equals to 4x to the power 3 over 2 there. And this one, it's really in between. X is equals to 0 and x is equals to 3 over 2. Is it 3 over 2 or 2 over 3? I think it's really 2 over 3, the way I saw it. Let me verify the bounds. The bounds is 2 over 3 and 0. So the lower fence is 0 and the upper fence is 2 over 3. You want to find the arc, the length of the arc. So I'm going to say that the length of the arc is going to be found by the square root of what is the integral from a to b of the square root of 1 plus the function, the derivative of the function squared dx, or you can say that that is s. S represents the length of the arc, that is from a to b of the square root of 1 plus f prime of x all squared dx. All right, and that should really suffice to the bounds. The bounds are what? Are from 0, the lower fence, to 2 over 3, you know. And then you get 1 plus the derivative of f. If you drive f, let's drive f primarily because we really need it. So that means that f prime at x is going to give us 6x to the power 1 over 2. Or you can say it's 6 root of x. One of the two is fine. So you are going to square that derivative, which is 6 root of x. Then you need to square that dx. And then now this will tie it down to from 0 to 2 over 3 into 1 plus, if you square 6, 36. If you square root x, you're going to get x dx. So you're back now to integrals again. So I'm just going to be doing it autonomously. That is to say that this is going to be, it's a substitution, you can see that. It's going to be 1 over 36 into, you add 1 to the half, so it's 3 over 2, which is 2 over 3, but your u is what is inside, so that is going to be 1 plus 6x to the power 3 over 2, the opposite of that one. You close that, and then you need to get your bounds, that is from 0 to 3 over 2. And as a result, this should really take away some stuff there. So that is 18 times 3. That is 1 over 54, right? And then you substitute the value there. So this should really be 1 plus 36 into 3 over 2. Everything to the power 3 over 2 there. I think this should be 2 over 3. This one should really be 2 over 3. What am I doing? 2 over 3. And then minus, that is 1 plus 36 times 0. Everything to the power 3 over 2. Let me just really close it. So that is 1 over 54 into, if you do that nicely, that is going to be 1 plus 2 times that divided by 3 to the power that should suffice to, let me confirm that, that should be 125 minus, this is really going to be 0. So you are left with 1 to the power that is, which is 1. So that is really that. And as a result, you are definitely going to get 1 over 54 into 124. And if you type it nicely in your Casio, that should really boil down to 62 divided by 27. This is how I will do the question, and thank you very much for watching. We've been here for hours now. Thank you so much for watching, and if there's any question, don't forget to comment, like, and share, and subscribe to the channel for more mathematics content.